Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. XOR queries of a subarray, Leetcode 1310. In this problem, we are given an array R of positive integers. We are also given the array queries, where queries I is equal to lefti to righti. For each query I, we need to compute the XOR of elements from lefti to righti. That is, array of lefti, XOR array of lefti plus 1, and so on. And finally, XOR array of right. Then we should return an array answer where answer I is the answer to the ith query. So basically we are given an array of integers and queries, and our output or answer should be of the length of the queries with answer to each of the query. Then in example 1, this is our given array and these are the queries. The binary representation of 1 can be 0001. Similarly, binary representation of 3 is 0011 and so on. And then for each query, we need to calculate our answer. So for example, first query is 0, 1. So that means we should go through the positions from index 0 to 1. That is, we do 1 XOR 3 and that will give us 2. And the reason is when we perform bitwise XOR, it outputs 1 if all the bits are different. Otherwise, it outputs 0. So let's do bitwise XOR between binary representation of 1 and 3. So 1 XOR 1 will be 0. Then 0 XOR 1 will give us 1 because the bits are different. Then 0 XOR 0 will give us 0. And finally, the 0 XOR 0 also gives us 0. So this binary representation results in integer 2 and that is our answer. Similarly, the next query is 1, 2. That is, we need to XOR all the values from index 1 to 2. So it will be 3 XOR 4. And then binary representation of 3 is 0011 and 4 is 0100. So if we do bitwise XOR, then it will be 1 XOR 0 will be 1. Then another 1 XOR 0 will be 1. Then 0 XOR 1 also will be 1. And finally 0 XOR 0 will give us 0. And this binary representation corresponds to integer 7. And that will be our answer for query number 1. Then query at index 2 is interesting. It is from 0 to 3. So that means we take the XOR of all the integers from index 0 to 3. So that means all the integers. So we will do 1 XOR 3 XOR 4 XOR 8. And that will give us 14. And the reason is first we do 1 XOR 3. That will give us 2. Then we do 2 XOR 4. So binary representation of 2 is 0010 and 4 is 0100. So that will give us 0110. So that implies 6. Then we will do bitwise XOR between 6 and 8. And we can see that it will result in 1110. And that will give us integer 14. And finally at index 3 in the query, we have 3, 3. So we don't have enough numbers to XOR. There is only one integer, that is 8. So we will just add 8 to our answer. And that's how we get output as 2, 7, 14 and 8. And this is the brute force approach where we will go through each query. And suppose we have q queries. And in the worst case, a query can have a range from 0 to n-1. So that means we will go through each element of the array and XOR them. And because of this, the time complexity will be O of q dot n, where q is number of queries and n is the number of elements in the array. And in terms of space complexity, it will be O of q because we have to return q queries as our answer. And now let's see how we can optimize it. And for that, let's look at some XOR properties. So when we do x XOR 0, we will get x. And the reason is, suppose a number is 0, 1, 1, 0. And if we XOR it with 0, all the ones that XOR with 0 actually will result in 1. Because if the bits are different, the output is 1. So whatever bits are set in the number will be outputted as 1. And whatever zeros exist in the number will be outputted as 0. So the number will not change and we will get x as an output. Similarly, if we do x XOR x, that will be 0 because again, let's take the number 0110 and XOR it with 0110 again. So whenever the bits are same, we will get 0. So 0 XOR 0 will be 0, 1 XOR 1 will be 0. So that's why the output will be 0. Similarly, with XOR, the order of operation doesn't matter. That is, it is associative. So if we do x XOR y or y XOR x, the result will be the same. Similarly, if we do x XOR y XOR z and then z XOR x XOR y, the output will still be the same. And now for our problem, we want the XOR value for a range. So we won't skip the numbers in the range. And we have seen similar problem with sum value for a range. And there we use the concept of prefix sum. And here let's see how prefix XOR works for us. Let's say that an array contains 4 integers a, b, c, d. I'm not looking at integer values specifically because I want to show how prefix XOR will work. So how will we calculate the prefix sum, or in this case prefix XOR? So we take first element as 0 and then the next element is 0 XOR a. And 0 XOR a will give us a because we saw x XOR 0 is x. Similarly, the next element will be a XOR b and then next element will be a XOR b XOR c. And Finally, the last element will be A's or B's or C's or D. So it will have XOR of all the numbers in the input array. So prefix sum has one element more than input array. And because of this, we have to look for one index more when selecting the element. And now let's see how this prefix sum can help us calculate this XOR between range in O of constant time. And for that, let's look at the queries again. First query is 0, 1. That means we need to XOR the values in the input array from index 0 to 1. That is, we need to have A's or B. Visually, we can see that B is stored at index 1. But for prefix value, for A's or B, we have to look at index 2. So when we are selecting a value, we have to look at one index more. Now we want the XOR value for the range 0 to 1. But when we look at the XOR value at index 2, we are actually looking at the XOR of this range. So we need to cancel out the XOR values before this range. And how do we cancel out? We actually just do the XOR of this array. So we can just take prefix sum of 2, XOR prefix sum of 0, and that will give us A's or B, right? And I think it will become more clear with the second query. So now our second query is 1, 2. So that means we want the XOR of numbers from index 1 to 2. So what is the prefix sum we should be looking at such that C is included? And the answer is we should be looking at prefix sum 3. But it will have A, XOR B, XOR C. But we don't want A in it. So how will we cancel out? We will just XOR it with the left part of the array. And in this case, it will be prefix sum 1. So if we XOR it with A, then A and A will cancel out. So we will get B XOR Z. So in general, for the range left to right, let's denote it with L, R. We will just take prefix XOR of right plus 1 because we added this extra element here. But it contains XOR of all the values from index 0 to R. So we want to cancel out all the values before the left. So we will do the XOR with prefix sum of left. So prefix sum of L plus 1 will include XOR values from 0 to L. But in the range L, R, element at index L has to be included. So that's why to include the element in index L, we have to take prefix sum of L instead of L plus 1. So we will just take a XOR with prefix XOR L and that will give us our answer. Now let's look at query 2. So it will be in the range 0, 3. So that means we take prefix sum of 4 and XOR it with prefix sum of 0. So that will give us A XOR, B XOR, C XOR, D. Finally, last query, we get the range 3, 3. So we will again take prefix sum of 4, that is A XOR, B XOR, C XOR, D, and XOR it with prefix sum of left. So it will be A XOR, B XOR, C. And because of this, A, B, and C will cancel out and we will have only D remaining. Now finding the XOR of numbers in the range L, R takes just O of 1 time. Because we are just doing prefix of R plus 1, XOR prefix of L, right? And now if we try to generate the XOR values for all the Q queries, it will take O of Q time. But when we are building the prefix query, now it takes O of N time for that. So because of this, overall the time complexity is O of N plus Q. And in terms of space complexity, earlier in the brute force solution, our space complexity was O of Q for storing the query results. But now we also need to store the prefix sum. So because of this, our space complexity becomes O of N plus Q. Now let's jump into the code part. So let's first define the prefix XOR, and now we will fill in the values in it by looping on the integer array. So we will just do prefix of I plus 1 is equal to previous prefix, that is prefix I, XOR the current element. And because integer array has a default value of 0, prefix of 0 will be 0 anyways. And now we can actually answer all the queries. So let's define the answer array. And it will be equal to length of queries array. Now let's loop on the queries and get left and right indices. And for left, it will be queries I0, and for right, it will be queries I1. And now we calculate ith answer as prefix of right plus 1, XOR prefix of left, and that's it. So now let's return our answers. Let's run this code. Let's submit this code. Awesome. I hope this video was useful to you. If it was, please like, share, and subscribe. The code link is in the description below. If you have any questions or suggestions, please write them in the comment box. Thank you for watching. Have a nice time.